Up to this point, we've talked about I squared, and a little about I to the third. What we're going to see today is what happens when we have a power of I that is not one of those three. So what happens if we have I to the 15th? What does that equal? How do we simplify it? Well, let's begin, before we start with I to the 15th, with reviewing what I was. Remember, I was the square root of -1. I squared we've used several times as being the square root of -1 times the square root of -1, which equaled -1. And I to the third, we said was I squared times I, or -I. Let's expand this to I to the fourth. Well, using our previous knowledge about exponents, we know that I to the fourth is made up of I squared times I squared. And I squared are simply -1 times -1, which gives us 1. So I to the fourth, we end up with a real number. If I continue this pattern, I to the fifth, using what we know, breaking it up however we want, arbitrarily I'll choose I to the fourth times I, because I know that I to the fourth equals 1. So I have 1 times I, or I. I to the sixth, I'm going to break up into I to the fourth, because I know that's 1, times I squared. Notice my exponents still add up to be 6. So I end up with I squared, which is really -1. So I have 1 times -1, which is -1. We should see that we've started to repeat our pattern up here. Let's see if this holds true for I to the seventh. Well, I have I to the fourth times I to the third, which will give me -I times 1, or -I. So I have repeated. Notice with I to the eighth, I can simply make it I to the fourth times I to the fourth, which is 1 times 1, or 1. And we'll see this pattern continue with larger exponents. So where does that leave us with I to the 15th? Well, let's think about how many 4s there are in 15. We should know that 4 times 3 gives us 12. And then we can break that up into I to the 12th times I to the third. So if we look at I to the 12th, that's going to simply be 1. So any exponent that's divisible by 4 is going to end up being 1. So we're left with I to the third, and we know I to the third equals -I. So I to the 15th really is just -I. This works for much larger exponents. Let's try I to the 39th. Well, I to the 39th, when we look at 39, the number, as we decrease it to get to a number that's divisible by 4, we know it's 36. And then I, in this case, is I to the third again. So we end up with 1 times I to the third, which is -I. Let's try one that doesn't end up in a third. Let's try I to the 48th. If I look at 48 I know is divisible by 4. So I know this answer is going to be 1. Let's look at I to the 121st. Notice our exponents are getting very large. However, if we think about 121, we can break this up into I to the 120th times I to the first. I to the 120th divisible by 4, so that's 1. I to the first is simply I, so I to the 121st is equal to I. And let's give one more just for good measure. Let's try I to the 74th. 74 is not divisible by 4. As we decrease it, we get to 72, which is divisible by 4. So 72 and 2, so I squared, gives us a 74. I to the 72nd again is 1. I squared in our chart is equal to -1. So we should hopefully see that I becomes cyclical after I to the 4th. That being said, I is going to equal I to the 5th, I squared equal to I to the 6th, I to the 3rd, I to the 7th, and I to the 4th, and I to the 8th are equal to each other. We can use that information to simplify larger exponents by taking a number out that's divisible by 4 and simplifying what's remaining.